Welcome back, everybody. So those of you playing along at home, no warm up today. I just handed out the quiz that you took last Thursday. So no warm up or anything. So as I was saying, section 3.5 and 3.6, we're going to spend several days on 3.5 and 3.6. 2 days on section 3.5, and then actually 3 days on section 3.6. By Wednesday of next week, we'll take our quiz over those two sections. Then we're going to recap, review, and then test over all of chapter 3 later on. Okay, probably like 2 weeks from today. All right, so what is section 3.5? Section 3.5 is all about graphing when the function is in standard form. Well, what is standard form? Standard form of an equation is written, and let me get a pen real quick, is when it's written in the form ax plus by equals c. So star it, highlight it, underline it, do whatever you need to do. This is important. Ax plus by equals c is the thing that's called standard form. Standard form of an equation. You know, standard form is the most forgotten about form. You know, I'd say slope-intercept form is the most commonly used one. By the end of the chapter, we're going to learn point slope form as well. But what we're looking at here is called standard form. Now, what is standard form? Well, standard form is just basically when it's lined up, x, y, constant. X, y, constant. X, y, and the number on the other side. Okay? Now, first thing that we're going to talk about when it's in standard form is, well, what does it look like when we have a horizontal and vertical line? Now, horizontal and vertical lines, we kind of talked about it a little bit already. When we introduced what a linear function was, we had that example where it was like y equals 8 or something like that. And I said any y equals line. Does anybody remember what type of line is a y equals? A horizontal line. Good. A y equals line is a horizontal line. Why? Why? Because no matter what my input is, y equals that number. So say it was like y equals 8 or whatever. Y equals 8. No matter what the input is, the output is 8. Negative 2, 8. Negative 3, 8. 7, 8. You're making a horizontal line. Okay, in contrast to that, what happens if it's an x equals? Well, it turns that horizontal line into a vertical line, which is no longer a function, let me remind you. Any vertical line is no longer a function. It's linear, but it's not a linear function. Any vertical line is an x equals line. So say it's an x equals negative 2. Well, it's a vertical line over negative 2. No matter what the output would be, the input is negative 2. The input is negative 2, and then the output is whatever it wants to be. Okay, let's practice that a little bit. It's kind of an easy concept. You just got to remember which goes with what. Like, for example, y equals 4. Horizontal or vertical line? Horizontal, because it's a y equals. So y equals 4. Full, complete line, arrows on the end. Okay. Part B. X equals negative 2. Okay, what type of line is that? Vertical at negative 2. Yes, literally that simple. Horizontal is y equals. Vertical is x equals. Okay. Couple more. Horizontal or vertical? Everybody. Vertical. X equals 4/3. Okay, that's like 1 1/3, so somewhere around right there. Hopefully without a little curve that I have on there. And part D, y equals negative 1.5. Horizontal or vertical? Horizontal at negative 1.5. Okay, that was hopefully pretty easy, right? You just have to remember you just have to be able to identify it when it comes across. Horizontal lines are y equals, vertical lines are x equals. Okay, now, flip it over onto the back. This is a diagram that I've shown you before, talking about intercepts. Guys, did you just do this on the quiz on Thursday?
Yes.
Identifying intercepts. You should know how to identify where they are given a graph. But what we're going to do here is take those equations and find the intercepts from them. Okay, now, you have this on your papers, the x-intercept and then a big blank, and then a y-intercept and a big blank. I'm going to ask you to fill in these 3 bullet points in that space provided. So, the x-intercept. The x-intercept is defined to be the point where the line crosses the x-axis. Remember, the x-axis is the vertical axis. So it's the point where the line crosses the vertical axis. The point where the line crosses the x-axis. Point where the line crosses the x-axis. The second thing is how we solve for it given an equation. And I'll tell you what, this is the most important thing today. How do you solve for it given an equation? You take y and turn it into 0, and then you resolve the equation for x. We say that again. You take y, let it equal 0, and then you resolve for your variable x. What are you going to get out in the end? A coordinate x comma 0. Again, I strongly encourage you to represent it as a coordinate x comma 0, where it's a number comma 0, like 4 comma 0, 3 comma 0, negative 2 comma 0. Okay, in contrast to that, let's talk about the y-intercept now. The y-intercept is the point where the line crosses the y-axis. The y-intercept has a y value. It's the point where the line crosses. I told you what to do right now. Do what I tell you to do. It's the point where the line crosses the y-axis. How do you solve for it? Well, you let x equal 0, then you resolve for y. So it's kind of the opposite of solving for the x-intercept. The x-intercept, you plug 0 in for y. The y-intercept, you plug 0 in for x. Because in the end, you want 0 comma the number. 0 comma 5, 0 comma 7, 0 comma negative 3. Those are the y-intercepts. So I'd like for you on the right side of those blanks to identify which one is the x and y-intercept and also give me the coordinate. Kind of basically exactly what you did on the test. Go ahead and do that. Identify which one is the x and y-intercept and also give me the coordinate. Do that right now. On the right side of that space provided. My diagram is just below it. Identify the x and y-intercepts and then give the coordinate. Here's what I mean. Where is my x-intercept? What's the coordinate of my x-intercept? Negative 3 comma 0. So this is the x-intercept. Negative 3 comma 0. I need to write that in. Here's the y-intercept. With coordinate 0 comma 7. Notice where the zeros are. The 0 goes in for the y coordinate on the x-intercept. The 0 goes in for the x coordinate on the y-intercept. Okay, let's take a couple problems and solve. So I'm given this equation. Notice that it's presented to you in standard form. You see it? X, y, number, 3x, 4y equals 12. Okay. So here's how we solve for each intercept. The second bullet point for the x-intercept said, let y equal 0. Okay. 3x plus 4 times 0 equal 12. Understand that what we're doing here is taking a number, comma, 0. Now, what's going to happen with 4 times 0? Yeah, what's going to happen when you take 4 times 0? It's going to be 0. So essentially, that term is going to just cancel out. I divide by 3, and I get x is equal to 4. Okay, that means it's 4, comma 0. That is my x-intercept. Okay, we solved for our x-intercept. Now let's solve for our y-intercept. The y-intercept is kind of the inverse of that. I plug 0 in for x and leave y in the equation. And now we solve for y. Well, in this case, what's going to happen with 3 times 0? Now that's going to turn into 0. That's going to go away. So now my y-intercept is 4y is equal to 12. So y is 3. 0, comma 3. Now, it is just a coincidence that those numbers end up being the opposite coefficients on our equation. That does not always happen. Don't trust that. Okay, that's just coincidental for these couple problems. It's going to happen on the next one too, but don't always think that's going to happen. So we have 4, comma 0. And then we have 0, comma 3. So I have 2 points. Graph your line between them. Do not just connect your dots. Graph the full and complete line with arrows on the end. Okay, let's try that again, shall we? I'll tell you what, most of the time when it's in standard form, the easiest way to graph the equation is to plot the intercept. Even after we learn what is slope-intercept form, y equals mx plus b. You're going to think that using slope-intercept form is the easiest all the time, but it's not. Okay, so again, I let y equal 0. So x plus 2 times 0 is negative 6. Well, that's fancy. What happens with my 2 times 0? Goes away. So x equals negative 6. Oh, man, that was easy. 0, comma, negative 6. On the flip side to that, I say 0 plus 2y is negative 6. Well, again, 0 plus 2y is just 2y. I divide by 2, y is negative 3. So this is 0, comma, negative 3, which is right there. And this is right here. And now I plot my line between them. Arrows and full line. Do not just connect your intercept. All the way through the edges of the graph. We're going to do that 2 more times. Do it again. Sorry, did anybody still need this? While we're waiting, it's a good time for me to point out, are we graphing now? Yes. Let me see everybody's eyes real quick. Everybody look at me. I need everybody to hear this. I will not accept your homework if it's not on graph paper. Okay? I will not accept your homework if it's not on graph paper. I've been telling you to get graph paper. I've been telling you since the beginning of the year you need to get graph paper. I will not accept your homework if it is not on graph paper. Everybody hear me on that? Everybody hear me out on the video? I will not accept your homework if it's not on graph paper. If you don't have graph paper, you have two options. You go and buy some, or you go and buy some. This link down here at the bottom of my homepage, printable graph paper. You just open that up and print it. It's just 12 graphs, okay? Print it to the Student Center. I mean, don't waste the school's resources. All right, let's take a look at this part C here. 3x minus 7y is equal to 21. Okay, so again, we plug y as 0. So 3x minus 7, do y as 0. 7 times 0 is equal to 21. So my 7y is going to go away. My 7 times 0 is going to go away, leaving me with only a 3x is 21. So I divide by 3. X is 7, which gives me the coordinate 7, 0. Do the same thing to solve for y. Except now we plug the 0 in for x. So 3 times 0 is 0. Minus 7y is 21. So divide by negative 7. See, again, this is one that's going to come out as just the other two numbers. Be careful, that's just a coincidence. So we have positive 7 and negative 3 as my intercepts. So 0, negative 3 is down here. 7, 0 is over here. And then we plot our line between them. Try to hit the points better than I did there. Now, parts A, B, and C were all in standard form, where I had x, then y, then the number. Is B the same way? No. Okay, so you really have two options. You could put it into standard form, or you could just work with it as it is. Let's just work with it as it is. Does the process change? Nope. So you say let y equal 0. 2x plus 4 equals 0. And now we solve for x. Okay, let's subtract over the 4. So we have 2x is equal to negative 4. We divide by 2. We get negative 2. We do the same thing for our y-intercept, but now we say 2 times 0 plus 4 is equal to y. Hey, that's convenient. The 2 times 0 is going to go away, so 4 is equal to y. So 0, 4, which actually you're going to see makes sense because wasn't I given that problem in slope-intercept form? Isn't that mx plus b form? Isn't the b 4? But again, we'll get there in section 3.6. So 0, 4, negative 2, 0, graph our line. Oh, yikes. Wow, I really missed my red point there. Questions about that? All right, let me say one more time. If it's not on graph paper, you do not get credit. Why am I being so picky? Because I don't want you. I know the way some of you guys write your words. I don't want to see you try to draw yourself a graph. Yikes. Okay, you need to keep yourself organized, and the best way to do that is to put it on graph paper. So, from here on out, if you graph, if any problem asks you to graph, and you do not use graph paper, Are you going to get credit for that homework? No. No exceptions. I'm going to keep this pile stacked right here. So if you ever want to grab a piece, if you're like in mentoring or something, you want to run over and grab a piece, by all means, go for it. Okay. All right. Everybody say bye to the folks at home.
Bye.